Okay, today we will start definite integral with the greatest integer function. Student face very difficulty this type of question. Generally we solve definite integral question without greatest integer very easy. But when we find greatest integer function in integration, many not most of the students find difficulty. So we will solve such type of integration. First one is very easy. Many students can solve this. So greatest integer function has property if x belongs to 0 to 1. If x belongs to 0 to 1, greatest integer of x is 0. If x greater than equal to 1, less than 2, greatest integer is 1. If x greater or equal to 2, less than 3, and its value is, if x is greater than minus 2, less than equal to minus 1, so it will become minus. If this minus 3 less than x less than minus 2, greatest integer is minus 3. So this is a very easy question. Many student can solve this very easily. So first we will break into integer. So we will break 0 to 1 x, greatest integer of x dx, plus 1 set to greatest integer of x dx. In between 0 to 1, as I have already told you, 0 to 1, its value is 0 to 1 dx, plus 1 to 2, greatest integer of, if x greater than equal to 1 and less than 2, its value is 1. So its value is 0 and its value is minus x 1 to 2. So taking limit 2 minus 1 is equal to 1. This will be the question. So this one is little bit difficult. X square 0 to 1, x value is 0 to 1. Now we will square x square 0 to 4. Now we will take its integer value. 0 to 4 में there are one integer value in 1 0, another one in 2, another one in 0 1 2 3 4. And if we take value of x again, so 0 1 root 2 root 3, and we will apply here, but first we will take the limit with respect to x. 0 to 2 is here, x square is equal to 0 to 4, and find the integer between 0 to 4, 0 1 2 3 4, and after that we will again find the value of x, 0 1 2 2 3. So now we will break it. 0 to 1, greatest integer of x square dx, 1 to 2, greatest integer of x square dx, plus root 2 to root 3, greatest integer of x square dx, plus root 3 to 2, root 3 to 4, greatest integer of x square. Now we will find its greatest integer value. Now we will find its greatest integer value. 0 to 1, it's 0 to 1, its value is 0. So 0 to 1, its value is 0 dx. 1 square it, sorry, greater sign, root 2 root 3, so it's become its value vibrate 2 to 3, so is greatest integer at 2dx plus if root 2 to root 3 to 2, so its value will be vibrate between 3 to 4, greater than 3 but less than 4, so it will become 3 root 3 to 2dx. So now we can, this will become 0, so 1 dx x 1 to root 2 plus 2 will be outside, this will become x root 2 to root 3, this will become 3 x root 3 to, now we will put the limit, so it will become root 2 minus 1 plus 2 root 3 minus root 2 plus 3 2 minus root 2. Now we will simplify it, root 2 minus 2 root 2, it will become minus root 2 or 2 root 3 minus 3 root 3, so it will become minus root 3, 3 to the 6 minus 1, so 5. So its answer will be 5 minus root 2 minus root 3. Right? 2 root 3 minus 3 root 3, it will become 3 root 3 root 2 minus 2 root 2 minus root 2, 3 to the 6. So this will be, this is a little bit difficult. This question I am asking JA. We will move to next question. This one is little bit tricky but easy question. If we draw the graph of sin 0 to 2 pi, 0 pi, its range will be 1 and minus. This is the graph of sine. Many students will be familiar with this, and I know, and I think everyone is familiar with this. So we will break into graph 0 to pi, so because 0 to pi this is upward and pi to 2 pi minus. 0 to 2 pi this is upward with horizontal x-axis, and pi to 2 pi this is below the horizontal line. But you know very well from the childhood, from the 10th class, sin x will be vibrate between plus 1 and minus. So we will break it 0 to pi sin x plus pi to 2 pi greatest integer of sin. But if you take the value from 0 to pi, it will touch maximum limit in pi, and it is very, if it takes slightly difference from here, pi by 2 minus h, pi by 2 plus h, after limit, if it takes slightly, limit 0 to pi, its maximum value is pi, but it touch only one point. So at every one point it is less than 1. So if, as I have already told you, x less than 1, so its value will be 0 to pi, 0 plus pi to 2 pi, it will become, this will vibrate 0 to minus 1. This will vibrate 0 to minus 1. will vibrate from 0 to -1, so it will be -1 dx. So 0 to pi it will be 0, -1 it will be x, pi to 2 pi, -1 upper limit 2 pi minus pi, so it will pi minus. This question has already asked in JEE exam. This is very easy question. Many students are very familiar with it. So -1 0 x minus greatest integer of x plus 0 to 1 x minus greatest integer of x. Now many students will ask me why to break it to 0 to -1 and -1, because this is a linear graph in greatest integer function. So we will break into linear integer. Linear variable we will break into simplest greatest integer. If we talk about -1 to 0, we have studied that the value is -1 to 0, so its value will be -1. So -1 to 0, x greatest integer of x is -1, so it will become +1. This is the important point here. If x value is variant -1 to 0, so greatest integer function is -1. And 0 to 1 x, if x vibrate from 0 to 1 and its greatest integer will be. So now integrate x square by 2 plus 1x minus 1 to 0 plus this will become x square upon 2 0 to 1. Now we will put, if we put upper limit 0, so it will become 0 minus, if we put minus 1 here, so it will become plus 1 square minus 1 plus 1 by 2. It will become minus 1 by 2 and minus 1 by 2 plus 1 by 2. 1 by 2 plus 1 by 2. It will become this is a little but difficult question. Maybe more than little question. More than difficult. This may be difficult for many students. If you put, this is a 10x graph. You know 10x graph is like this. 10x graph like this, minus 1 by 2 plus 1. If you put the value, respective value from here, tan 0 is 0, tan 0 is 0, tan 5 pi by 12. 5 pi by 12 means 5 pi by 12 means 75. 5 pi by 12 is tan 75. Tan 75 value is 2 plus 2. You can calculate and many students has remembered. So if you will put, so its value will be 2 plus 1.73, 3.7. So its value will be vibrate tan inverse 3.73, इसके बीच में 0, 1, 2, 3, 3.7. So this is the value of tan. Then now we will break it 0 to, this is the value of tan x. So 0 से tan inverse 1 dx, sorry, greatest integer of tan x plus tan inverse 1 to tan inverse 2, greatest integer of tan x. I am removing it. Plus now tan inverse 2 to tan inverse 3, greatest integer of tan x, plus tan inverse 3 to 3, it will become 2 plus 2. This will be tan inverse greatest integer of x. Between 0 to tan 1, its value will be 0. So its value will be 0, 0 to tan inverse 1. Its value will be 0. To tan inverse 1, its value will be 0. Tan inverse 1 to tan inverse 2, its value will be 1, because 1 and 2, its value will be 1, plus tan inverse 1, tan inverse 2 to tan inverse 3, its value will be 2, plus tan inverse 3 tan inverse 3, after that tan inverse 5, it will become 5 pi by 5 pi by. Now we will this will become 0. This will become 0, or x tan inverse 2 minus tan inverse 1 plus 2, यहाँ पर it will be x, then it will be tan inverse minus tan inverse 3 minus tan inverse 2 plus, I am going to take this, plus 3 tan inverse 3 minus 5 pi by 1. Tan inverse 2 minus tan inverse 2, it will become, if we club this, tan inverse 2 minus 2 tan inverse 2, then it will become minus tan inverse 2. Slightly mistake. 3 5 pi by 12. Upper limit is this minus tan inverse 3. So if we club this tan inverse 2 minus 2 tan inverse 2, it will be minus tan inverse 2. And if we club this 2 tan inverse 3 minus 3 tan inverse 3, it will become minus tan inverse 3, and this is tan inverse 1, so it will become minus pi by 4. And one more thing will be remain here, this will become 5 pi by 4 plus 5 pi by 4. I am removing this. 5 pi by 4 and minus pi by 4 will become pi, and now we will take common tan inverse 2 plus tan inverse. Now we will apply tan inverse x plus tan inverse y formula be careful for applying this formula. So it will become tan inverse x plus y or 1 minus xy if xy less than 1. But if xy less than 1. If xy is not less than 1, so we cannot apply this formula. We will apply here tan inverse x plus tan inverse y is equal to y plus. Please be careful. This property had us many times in KEAD 1. Tan inverse x plus tan inverse y will be pi plus tan inverse x plus y 1 minus xy if xy greater than 1. So I will solve it in next way. We have y minus tan inverse 2 plus tan inverse 3. Tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy if xy less than 1. If xy less than 1, we will apply this formula. But if xy greater than 1, formula will be same pi plus tan inverse x plus y upon 1 minus xy. So it will become pi minus pi plus tan inverse 2 plus 3 1 minus 2 into pi minus pi plus tan inverse 5 upon minus 5. So pi minus pi tan inverse minus 1. Again tan inverse minus x is equal to minus tan inverse x. So it will become minus tan inverse 1. So this will cancel. Minus minus plus tan inverse 1. Tan inverse 1 is equal to pi by 4. So this is the little bit difficult. So many identities and inverse function we have, inverse function formulas we have used this. So okay, this is the small introduction of definite integration with the help of greater